Just like we talked about the idea that an acid has a pH less than 7, a base has a pH greater than 7. Bases can be molecular or ionic substances, and the narrowest definition is an Arrhenius base. This is one where, when it's dissolved in water, it increases the concentration of hydroxide ions. So the example is potassium hydroxide. Dissolve it in water, and we get hydroxide ions. But as chemists figured out that that was not broad enough, they came out with the Bronsted-Lowry definition. That's the one we're going to focus on most of the time. Those are proton acceptors. So here is ammonia accepting a proton from the HCl or accepting a proton from the acetic acid, turning into the ammonium cation. And the most general definition, which includes the 3 examples we looked at previously and this last one, a Lewis base is an electron pair donor. So this fluoride ion has some lone pairs in the outer valence shell, and one of them gets donated to BF3. So it is a Lewis base. These others are also Lewis bases because hydroxide and nitrogen also have lone pairs of electrons. So just like acids, bases come in strong and weak based on their behavior as electrolytes. It looks like the strong base list is bigger than the strong acid list, but it's really not that bad. Everything in the first group is a group 1 ion. And in the second group, it's the bottom half of the group 2 ions. So group 1 and calcium, strontium, barium, those are our strong bases. Those completely ionize in water 100%, and they make hydroxide ions. All the rest of them that you will use are weak. The weak ones, unfortunately, are a teeny bit more complicated. They come in 3 flavors: insoluble hydroxides, note the double arrow, so they will form hydroxide ions. An example of that would be iron 3 hydroxide. Nitrogenous bases, those are ones you're going to see a lot of. Those form hydroxide ions, and the base gets the hydrogen ion because bases are proton acceptors. So if ammonia is our base, ammonium ion is our product. And the last one, cations. Sorry, anions. Anions, not all, but some, in water are going to form hydroxide ions and leave what we're calling HB. In an example, carbonate ions are pretty basic. They have a fairly high pH when you dissolve them in water, because what happens is they form hydroxide ions and HCO3 minus. So we've taken a look at 3 different types of bases, strong and weak, and 3 different types of weak bases. Now you'll be able to put them all together and write some balanced equations.